Adding and subtracting fractions challenge problem. So I would attack this problem by doing 2 at a time. So let's look at 5, 6 plus 2 12s. When we add fractions, we need a common denominator. So we ask ourselves if we can make both denominators 6 or we can make both denominators 12. In this case, actually either is true, but sometimes it's easier to do multiplication. So if I multiply this first fraction by 2, multiplying both the numerator and denominator, I get 10 12s plus 2 12s. When we add fractions, we keep the denominator the same and we just add across the numerator. So 10 plus 2 is 10, 11, 12, which gives us 12 over 12. Now this is the same thing as 1, so I could use either as I add the last part, which is the minus 7 over 24. There are a few ways that I could look at it. I could look at it as either 1 minus 7 over 24, or I can look at it as 12 over 12 minus 7 over 24, and both would work out just fine. I could show that either way it's going to give us the same answer. So I'm going to look at both. If I look at it as 1 minus 7 over 24, you have to realize that 1 we can rewrite as the same numerator and denominator on top of each other, just to match the other denominator. So since this denominator is 24, I could write 1 as 24 over 24. And that's what I meant by that wordy explanation, that I can make the numerator and denominator the same, and that is the same thing as 1. So 1 is the same thing as 2 over 2, or 3 over 3, or 4 over 4, or 5 over 4, 5 over 5, or 6 over 6, so on and so on. But you're just going to pick whatever the denominator is, so that way you could actually subtract, because when we do subtraction, we keep the denominator the same, and we subtract across the top. So 24 minus 7 is 17. And we always could ask, can I reduce? Which I can in this case. And that's my final answer. Or I could use the 12 over 12 minus 7 over 24. In this case, I need a common denominator. So I would either want to make both denominators 12 or both denominators 24. In this case, I'm going to make both denominators 24 by multiplying 12 over 12 by 2. I get 24 over 24. And notice this is exactly the same thing that I had over here, which gives 17 over 24. This isn't the only way to do this problem. When I went back over here to the original, I could have realized that I could have divided the top and bottom of this by 2, which would have given me 1/6. Notice when I plug 1/6 in, I would get 5/6 plus 1/6, which gives me 6/6, and the rest is the same. This is 6/6 is the same thing as 1, which then leads me to this path, or I could have used 6 over 6 and made that 24 on the bottom by multiplying the top and bottom by 3.